All right, so as we go through this next example, I think it would be a good idea for you to pause the video a few times and see if you can work through the problem one part at a time. So we said the first step that we want to do is, well, actually, let's read the problem. We're asked to find y, a function of x. We want it to be the particular solution to dy dx equals y squared times x minus 1. And we're given the initial condition that f of 0 equals -3. So even though that's not given to us as an ordered pair, we could think of that as the ordered pair 0, -3. We said our first step to doing this is to separate. So take a moment, pause this video, and separate our differential equation into two parts. All right, I'm hoping you tried that part. All right, so we said for our separate step that we're gonna multiply the dx to the other side. So we get dy equals y squared times x minus 1 times dx. And that we need to keep all the x stuff with the dx, and we need to get the y squared to the other side. So if we divide both sides by y squared, we could now just rewrite that as, I'm going to write that as 1 over y squared. 1 over y squared dy equals x minus 1 dx. All right, so now I would like you to pause the video in just a moment and try the next step. So he said after we separate, we integrate. So pause and try that step on your own. All right, going to the integration step. I'm going to rewrite, instead of 1 over y squared, I'm going to rewrite that as y to the -2 power, because we're going to use our power rule on that. And then we'll keep our x minus 1 dx. Those parentheses aren't really necessary. They're kind of always implied that the function that we're integrating is in parentheses, so it's okay if you drop them there. All right, as we integrate on the left side the antiderivative of y to the -2 power, we're going to use our power rule. So we're going to add 1 to the exponent, which makes that y to the -1, and then divide by our new exponent, -1. And remember, dividing by -1 is the same as multiplying by -1. On the right side, we are going to integrate x minus 1 with respect to x. So that's going to become 1/2 x squared minus x plus c. All right, so that is the integration step. We said from here that our next two steps can be done in either order, that we still need to isolate y, and we also need to plug in our initial condition of 0, -3, and we need to find our c value. Honestly, sometimes it's easier to do one than the other. It's sometimes hard to tell which is going to be the easiest. I would recommend that you start with finding c first, and if you run into an issue, you can't find c, then maybe go back and try to isolate y. I think we should find c first. So there's something that I'd probably rewrite this first before I do that. Let's see, in this step I'm gonna say find c. Instead of writing this as -y to the -1 power, I would probably rewrite this as 1 over y, or sorry, -1 over y. But from here, see if you can plug in the initial condition and find c for yourself. So go ahead and pause the video and try that. All right, I'm assuming that you paused. All right, so as we plug in this initial condition, 0, -3, Anywhere I see my y, I'm going to plug in a -3. And I would still show work here, even though I know everything except for c is going to go to 0. You really want to show your work. And actually, while I'm thinking about it, in step 2, when you integrate, if you forget the plus c there, the AP graders will stop grading. If this is an FRQ, they will stop grading right there. So like, you cannot forget the plus c. It's very important. Even if you recover it in a later step, they will likely not grade the rest of the question. So, all right, so we're finding c. -1 over -3, that's just a positive 1/3. And then we said all of our x's go to 0, so we get positive 1/3 equals c. So that is our c value that we need. Lastly, we're going to solve the equation for y, and since we know c already, we should go ahead and plug it in. Let's see, so our equation again is -1 over y equals 1/2 x squared minus x. But now, instead of saying plus c, we're going to write plus 1/3, because this is the particular solution that meets the criteria of the initial condition. So personally, what I would do here, you could really, you could flip both sides of the fraction and make the right side its reciprocal, but I think there's a potential for a lot of mistakes there. What I would do to solve for y is I would multiply both sides of this equation by y first. So when we do that to the left, those y's undo one another. We do that to the right, we've got y by itself. Then I'd go back and rewrite this -1 equals, and then it's just all this junk times y. The parentheses do matter here, so 1/2 x squared minus x plus 1/3, all of that times y. So now to isolate y, we could just divide both sides by all that junk in parentheses. So we get y equals, I'm just going to keep my negative with the 1. I'm going to put it in the numerator, or we could leave it out in front. The parentheses in the denominator don't really matter because they are implied, but sometimes I like to write them anyways. All right, so we get y equals -1 over all that junk. Awesome.